Hello, welcome back to BlenderSushi Live Noding. This time in this video, I'm gonna go through the concept of random numbers or random vectors and noise. Random and noise are two important concepts when doing procedural modeling or procedural animations, all kind of procedural um, generations, like a generative design. You will encounter random and noise. Let's just have a look a couple of things. Probably not very noticeable, but sometimes with Sverchok, even just by combining few things, you can get like interesting result. So yeah, let's just explore. Let's say start with random vector. I'm gonna see, we can't see the result, but normally even with just a single node like that, I create a view draw right away to see what the result is. So that's basically random points or random vectors in 3D space. You can bake it and get a random points like that, and can use it for other things. If you wanna have a look at the values, you can do it like that, and just open the text editor and go and have a look at Sverchok viewer. So that's the points being generated all in order like that. That's yeah, that's points. I mean, you can play around with the seed. It's really random, even though it's not so beautiful. It can be really handy, especially when you combine it with noise. Let's say I'm gonna save it real quick. Random and noise. Just gonna explore this real quick. Let's say you could mix random with noise, for example. Let's try vector noise. Plug that in. Plug that in. And at the moment we don't see much, but if we actually use math, actually vector math, and just add it, vector in, if we actually kind of push the random vectors through the noise, it started to look like birds flocking, or like, yeah, something like that. So you can use frame, info nodes, plug into the vector. If we play back, it looks really fast, but we can use math and just multiply it by a smaller number. So smaller number, it works really well. So it's like just like a bunch of birds flocking in the air. Yeah, that's one thing you can do with random vectors and vector noise. What else? Let's see. Let's see if we increase it or reduce it. So nothing. What else we can do with random? We could probably use a hull, convex hull. Let's plug it in there. And you get something that looking like a stone. Maybe we can have like a vector math here, and then use a scalar, multiply by scalar for let's see what's the result real quick. So that's with scale of 1, scale of, we can make it smaller. Maybe even let's get the noise back. Spectrum noise and scale it. It's get interesting when the value is quite low, like that. It's almost resembling like a stones or pebbles, kind of. Maybe have smaller value. Random seed. If you hit bake, you're gonna get that. See, maybe at this time you're thinking, okay, maybe you wanna have like a random. You want to have this generation, like a bunch of this stones, but in different variations like that. You can go into the monad or create a matrix thing, but like I said, you could actually just bake this for every frames, and you might notice that whenever I hit the button here, it's gonna call this PPY ops nodes Sverchok mesh baker mk2 blah blah blah. We can just copy this guy and then use animation nodes and then just quickly create a script node. And let's create a text and then display the text and then paste it there. And before we do anything, we turn off auto execution, and we want it to be executed on every frame change. Okay. Before we do that, we want to go back to Sverchok, and then we want like random generations per frame, so we can use frame info plug into the seed. Okay, now it's already animation node's already doing something. Let's go back and then have the script ready. I'm gonna delete everything, so just left with that guy. If I go just change any frame, yeah, so animation node is generating stones per frame, as you can see there. So gee, that's pretty cool. It's generating a lot. There is one trick you can use. Instead of generating every frames, we can kind of skip the frame. Let's say, okay, with the script here, at the moment it's calling this script every frame change, but we can tell animation nodes, okay, only run the script if the frame number is 0 when divided. I'm using this modulus operations, and then so if I'm doing it like this, this means every 5 frames generate the stone. We can change it to 10, so every 10 frames generate the stones. But we need a frame input, so I'm gonna create an integer, or yeah, integer is fine. This is gonna be the frame, and so the frame goes in, plug it in there. We got this float to integer because the frame in animation nodes is floating values. So only when gonna show it to you. Only when the frame is can be divided by 5, we're gonna have the stone being generated. So let's try that. just play back. See, when the frame is hitting 45, 50, it's actually different. If the frame number divided by 10 equals 0, that means every 10 frames we're gonna have like the stone being generated. So something like that. So we have less stone. And with this guy, as you already know, we could then arrange the stone if you like. We can use objects, selected objects. See, I'm gonna use this magic node. Loop through every. I'm selecting the stone, right? And then I'm gonna transform the objects. Probably arrange it in a maybe grid kind of arrangement. Factories, plug in there, arrange it. Like that. So we have kind of stone generators using Sverchok, and the animation nodes will do the baking. So it's kind of like teamwork. Very, very nice. We can smooth it. Yeah, so that will work perfectly. Okay, other than that, let's see what other thing noise can do. Compositing back to Sverchok. Noise at random. Noise. With noise, we could actually create kind of like a snakes. I tried this the other day and it's working really well. It's kind of, the noise is kind of like wiggle in animation nodes. So if you wiggle like a line, it's gonna create like a kind of like a snake kind of motion like that. Let's just have a look real quick. So Sverchok, let's generate a vector noise object mesh, viewer draw, plugin vertices. So when you plug in the vector noise, we don't get anything right away, unlike the random. We need to have like an input, maybe lines, let's say line, plug in there. By default, it's almost like random, but if we reduce the step, like maybe generate 10 points and then reduce the step maybe 0.04, you start to see that the line, it's kind of, it's more like a harmonic, or it's not too random anymore. In fact, if we push the line, we're gonna get like a kind of like a snake kind of movement. Push it, to push it, we use the add operations, vertices, and maybe I use the wrong operations. It needs to be vector math. It's gonna be add vector in. Vector in is gonna be frame. So let's say we have like 20 of them, and increase the stepping a little bit and push the line, so we get something that looks like a kind of like scribble on air, or even a snake. I remember there's this shot for the movie Snakes on the Plane, and I think the effects was done by Cafe FX Studio. I don't know. There is one scene where they have like hundreds or thousands of snakes kind of moving around and then kind of sliding. I think they use this kind of technique, like noise. Then the snakes are not touching each other. They're kind of touching, but they're also pushing each other. I think that's quite beautiful. You probably can use similar kind of idea. Frame. If I push it using frame, maybe reduce the speed a little bit. Let's have a look. So that's a bit quick. Maybe 0.1. Save this. So random and noise. If I haven't mentioned it already, with random you have a kind of value that jumps really like a more random between 0 and 1, while with noise you have a value that's more like kind of smooth, like that. So that's a two different kind of generator. They're very useful. If you want more, you have this like a math function that's doing this. It's called sine. It's all basic, and I probably already used it many times. Noise, and then you can also have value that goes like this, on and off. Square, we call it square, and that's saw. Is that saw? I think there's also another one that goes like this. So it's all functions. You will encounter it eventually. Anyway, with the snake, yeah, if we plug in the edge there, we're gonna get, yeah, it's more like a snake. You could use the monad thing here, the monad and vectorization. It will work. Maybe we don't even need the monad. Let's see. The seed is in the. Where's the seed? It's the vertices. Maybe the step. Whoops, not the step. 0.01. Not the step. We can actually kind of delay. I believe we could delay the frame just like in animation nodes. So if we offset the time, maybe we're gonna do that a little bit later. Maybe I'm gonna use something. There's a pipe node in Sverchok. If we plug in the vertices and edges, and then let's see what it's gonna result in. You're gonna get kind of like a almost like a when you have a curve and then you extrude it, but it can do more actually. This pipe tube node is quite powerful and useful. I believe with the size we could actually okay, that's the fill, that's the, oh, okay, we can have it like that. Very motion graphic kind of look, round. We'll leave it like that. Size, the size is for the scaling. I believe we could actually randomize the size. I haven't tried that. Maybe give it a go. Size, do we have curve here? Interpolation, vector interpolations for the size. I haven't tried this. Vector in. This is join. Let's join. This kind of thing. You just kind of need to try it because with Sverchok, unless you're familiar, maybe all of this seems confusing. Even for me, sometimes I need to check the example and documentations. Oh, I'll try random. It's not giving me anything. Random process value. I never tried like that. Okay, that's really weird. Range float. Range float. Let's count between 0 and 1. Give it. We can do it like that. How many? Okay, that's 20 vertices, so just give it 20. This is a random value, so it's maybe the effect is a bit too crazy. Yeah, maybe don't use random. Use this instead. Sometimes we use like a trial and error. So that's actually working almost quite nicely. 019. So here we have like a vector value that goes from 0.24 and 0, and then this guy is kind of interpolating it. Maybe if I have like a start from 0 and then goes to like any number, small number, then goes back to 0, so it's more like it's kind of the value is kind of going up and going down in linear fashions. Let's delete grease pencil. So yeah, so it's kind of nice. All the nice thing we can do using just simple nodes like that. The pipe and then this vector noise and time. With the time we can actually randomize it. Maybe I should do that, maybe I shouldn't. Let's give it a go. This might fail, but if this works, it's gonna be really interesting. This is the multiplier. If I use add, it's gonna further like offset the time, I believe. If we are offsetting the times, we're gonna get a different looking snake. So that's offsetting the time. Maybe I should do it right here. Unplug that, put it here. Plug in the time. Yeah, I think Blender, oh, almost crashed. Interesting. Maybe animation nodes is doing something. No, we don't have animation nodes. Back to Sverchok. This is the line. Vertices. Maybe the other day I pushed. Maybe I put the offset either on the time or on the line. Let's increase the step a little bit. You can have longer snakes. Yeah, it's really cool effects. Almost like worms as well. 30. Kind of want it slightly larger. noise. I wonder if I could just use a vector math in here and then use scalar. So that increases the noise, and then yeah, that's much more natural. So let's attempt to do this monad thing. We're gonna put the line in there. What's gonna be the value that's randomizing the snakes? It's gonna be just the time, I guess. Let's try just select all of them and then Control G. Now we are inside the monad. So multiplier. Let's just quickly do this and plus. That's gonna be for the time, and second one's gonna be the offset. Let's name it offset, and it's gonna be time value goes in. Just gonna leave it like that. Delete the fever draw inside the monad and just connect the output right there. Go up. I will quickly vectorize, split, and check it on the fever. See what we got. Maybe let's give it a go with a matrix thing. Matrix in. We're gonna create some variations. First, we're gonna duplicate it. Vector in. I'm just gonna use line. So make 5 of them, and this is gonna be pushing the worms inside the noise. So let's create like a float range of integer. And so integer range integer. Where is it? Do it again. Range integer, and it's gonna start from 0, step 1, stop 10. Let's just count. Step 5, maybe count 10 different 5 different variations. Let's plug in there. And so now each of the worms is actually being pushed 5 frames ahead. If I just step it 1, so now each one of them is only like being offset or delay by 1 frame. Kind of similar if you're using animation nodes and you use a delay time nodes. This is kind of what's actually going on. But here with the noise, the thing with the random numbers and noise, they are actually kind of like a pseudo numbers. The numbers are already there, and all we do is kind of using the numbers. Here, if I increase the step like 25 or something, they're now behaving quite differently. The other day it wasn't this slow. Maybe I did something different the other day, but you could have a lot like of this guy. Let's see, I use integer. This is gonna go inside the count. If I zero out the step of the line, it's gonna create its worm being generated on the same place like that, and if I play it back, maybe I go inside the monad and increase the how fat this worm is gonna be. Probably because I'm using this random inside this guy, so it's slowing things down a little bit. Maybe if I just full screen it to the view full, let's have a look. Grab the timeline. It's actually really fast. It's interactive right here. When we play it back, still quite interactive. Can be faster, I think, if we turn off the maybe I don't use the poly. Maybe just generate the vertices. Cannot. Polygon. We could just use the lines like that, maybe. Oh no, it didn't work. Never mind. Let's get back. Oh, actually, I forgot to turn on the points. So go back into monad. Instead of pipe tube node, we just use the line edge. Okay, with just the point, it's pretty fast. Go inside the monad. This is vector line, goes into edge, goes into the poly. Maybe I need to plug that in. Oh well, turn on ambient occlusions. And see what we got. Turn on edge, turn off. That's actually turning on the shading, turn off the points. Save this. Yeah, so that's with a random and noise. Actually, we didn't use random, but that's with the noise. We can have maybe 20 or 100 of them. They look quite complex like that. Quite nice actually. That cap doesn't work. But that's kind of what you can get real quick using noise. It's a bunch of moving worms. Yeah, so random and noise. What else can we do? Let's save this. We can actually stop it right here, but maybe I'll try one more. If we have like grid line plane, have a plane, whoops, Sverchok just crashes. Oh, Blender just crashes. Okay, don't worry, we save. Let's wait few seconds, let it to load. Okay, good. We are back. Let's go to compositing. Back to Sverchok. With Sverchok, like I said before, it's really powerful when you're working with mesh. Let's say you have plane. Let's have a look at inside the plane. Viewer draw. We have this. Let's say make it 10 by 10. Okay. Maybe turn on the light. Turn off the points. So we have plane like this. What can we do with the plane? We can use random. Let's randomize this guy. There's actually randomized input vertices, and this is a handy node that kind of does it for you. Let's say if we just add a noise in the Z, that's actually a noise. It's not a random. It's probably random. I don't know. Let's try to push the vector and have a look what's gonna happen. Let's add it, vector in, and then just push it. Oh, of course that's gonna push the vertices, not the noise. With the amplitude, with the seed. So this is like a random noise. Let's try using, instead of random, let's try using noise instead. Vertices goes in there, this goes in there. So that's a vector noise. It's kind of doing it in every directions. Maybe we need it only in one axis. Yeah, let's have a look. Vertices go into vector noise. Do we have a 2D noise math? We have sine, modulo. Interesting. Vertices goes in there. Let's have a vector out and vector in. Lots of trial and error, but this is the fun, actually the fun part. For the X and Y, this goes in there. Maybe the Z can be randomized. It's math. Let's use plus. Plug in there and plug in there, and then vertices, and we get nothing. Which is quite interesting. Let's have a look at the data. Maybe the value is too small. Zero, zero, zero. It's super interesting. Why is it 0, 0, 0? It's value going out. Wait. Vector noise 0, 0, 0. A Voronoi is giving a value. Blender 0, 0, 0. If there's, that could be a bug actually. That's cell noise. Neoperlin 0, 0, 0. Wow, that's probably a bug. There's crackles. At least the crackle is working. I can increase the grid. Let's have a look. Smaller step. So that's our mesh result with a Voronoi crackle. I wonder if we can scale it up or down. Noise vector, probably here. Vector math and scalar. Vector cell noise. There's a scalar cell noise and vector cell noise in here. Which is this guy. Multiply by a scalar. Let's do it. Do it like this. Okay, so it's scaling the vector, so that's good. That's good. That's working. Increase this to 50 by 50. Scale it down even more. So that's nice. 80 by 80. That's crackle, and we can probably push it. I don't know. I think something wrong. There's something wrong with this. Oh, okay, there's apparently it was too small. The noise was too small, and then so after I increase it, we can actually start to see something. Interesting. Now we can probably push the noise as well, but I'm not gonna do that. Gonna try Voronoi 493, 492. Perlin, Neoperlin, cell noise, and Blender. Everything works. Cell noise is nice. This is just like when you use the displace modifier in Blender. If you have like a mesh and then use displace modifier, it's kind of doing the same thing, but doing it using functions. There's a displace modifier, and you use image. Of course, this is more kind of more visual. Either way, if you are inside Sverchok and doing it this, you can use the numbers to generate like a procedural mesh or even animations inside Sverchok. Let me check what else. Because here we have like plane. Maybe we want to change it into stripe box. Let's see what happens if I plug in the box. A lot of possibility. Get that. Maybe increase the resolutions. 10 by 10 by 10. Size. Box probably not gonna work. Doesn't have a UV. And we are using a scalar instead of vector noise. Maybe switch it to vector. with a sphere, or let's try sphere. So we're gonna do it differently. Vector in, vector out. Sphere goes inside that guy. Actually, inside this guy first, and then goes to there. And then do the vector math. Vector math, and just push the vector of this sphere and plug in there. And have a look. That's the sphere being destroyed by the noise. That's because it's a cell noise. Let's try new Berlin. Turn off the points. That's what we got. Maybe reduce the strength. So that's the effects of noise functions to this object. And in order to push this, we gotta maybe use another vector math. Let's do it here. So that's the noise pushing the objects. And because it's a 3D noise, you can use anything like even like a Suzanne head, or do we have torus inside Sverchok? We don't have a torus. Maybe just have a Suzanne object. Objects in, get the selections, Suzanne. Now let's push Suzanne. Yeah, that's noise function. It's kind of like Suzanne is inside the oceans and doing that. Yeah, let's see what else I could do with a random and noise. Vector noise sort. There's a Nero there. It's interesting. We can push the text. I guess that's pretty much it. I could show you. There are lots of things you can do with noise. See, line, plane, the effects of noise for lines, maybe. Maybe gonna save that for next time. Okay, so yeah, hopefully you find this video useful. I'm gonna see you on the next video. If you want to leave a comments or questions, please do. And yeah, thank you for tuning in. I'll see you